Can you imagine slowly losing the ability to live life as you know it? To slowly lose the ability to see, to walk, to grab an object, all the while experiencing pain, fatigue, and depression? These broad symptoms impact the quality of life of patients with a debilitating autoimmune disease that affects the brain and spinal cord, called multiple sclerosis, MS. MS affects many people worldwide, including young adults. Unfortunately, there is no cure for MS, but researchers are working hard to develop strategies to combat this devastating disease. What exactly happens to the brain and spinal cord in patients with MS? The brain and spinal cord are made up of neurons, a type of cell that delivers information from the brain to the spinal cord and then to the rest of the body, where it tells your body to carry out its important functions, like breathing and moving your muscles. The information is delivered through the part of the neuron called the axon, which is a long projection that acts like an electrical wire. Much like electrical wires send signals and are surrounded by insulation, axons carry the information and are wrapped in a protective material called myelin, which helps the information transmitted along the neurons flow more efficiently. In patients with MS, the myelin insulation around the neurons becomes damaged, so the signals from your brain to the rest of the body go haywire. Why does this happen? It is mainly due to immune cells. The immune system is our body's natural defense system. It keeps us healthy by recognizing and killing foreign invaders that cause disease or infection, such as bacteria or viruses. However, in MS, immune cells go awry, and instead of attacking foreign pathogens, they begin attacking the protective myelin that surrounds the nerves. This eventually damages both the neurons themselves and the cells that produce myelin, which are called oligodendrocytes. All of the current FDA-approved treatments for MS limit the destructive immune cells from entering the brain and spinal cord to try to stop them from damaging myelin. However, these treatments don't do anything to help replace the damaged neurons and oligodendrocytes in these patients. Instead of trying to repair a broken machine piece by piece, currently available treatments only prevent the machine from enduring further damage. A collaboration of scientists led by Dr. Craig Walsh from UC Irvine are taking a new approach to treating MS, a regenerative approach. Their strategy involves transplanting a type of cell called neural precursor cell, NPC, into the brain and spinal cord. What are NPCs? This is a group of cells that can become 3 different cell types, including neurons and oligodendrocytes, the cells that produce myelin. The idea is that if healthy NPCs are transplanted, these cells can first make new neurons to replace the ones that are damaged in MS. Second, make healthy oligodendrocytes, which can make more myelin to insulate the neurons. And third, regulate the immune system. Amazingly, this treatment works. Mouse NPCs transplanted into mice that had damaged neurons in their spinal cords could become oligodendrocytes, leading to increased production of myelin around the axons of neurons. And the researchers also found that damaged neurons were replaced with healthy ones. The scientists are now hard at work trying to figure out how exactly NPCs help repair damaged neurons and boost the immune system, and to use this information to design new therapies for MS. Overall, the research currently being done by these scientists is a promising step in treating patients with this disease. As we build on the progress enabled by California's Stem Cell Research and Therapy Development Program, we must keep the momentum going. We now have more advanced tools to develop better ways to treat devastating autoimmune diseases such as MS. Only with continued support for biomedical research can we increase our understanding of the therapeutic potential of stem cells and translate that understanding into meaningful treatments that help give patients their lives back.